This is a problem in which we are going to use both simple interest and compound interest formulas. So let's read the question. A couple starts a college fund for their new baby. They deposit $25,000 in an account. So that's the present value of money. So at this time, they deposit $25,000. The interest rate is 4.25%. It's not enough to know the interest rate. We need to know what kind of interest. So here clearly it says simple interest. So we know we need to use the simple interest formula, at least for the first 6 years. So let's write down this information. So step 1 is a simple interest account, and the starting amount or the principal value or the present value is $25,000. The rate of interest is 0.0425. So the percentage 4.25 is converted to a decimal, and we shift the decimal point to the left by 2 decimal place values. It's simple interest, and we need to also know the amount of time that $25,000 sits in this account. So it's for 6 years. Another important thing to note is that the time is measured in years, and that's exactly how it needs to be in order to plug it into any interest formula. So the simple interest formula for the amount accumulated, so that's the future value of the money, is A equals P times 1 plus RT. It's a simple interest formula, and that's why the formula is so simple. So the amount accumulated is $25,000 times 1 plus 0.0425 times the time t, which is 6 years. Now we just enter it all into the calculator, making sure that we have parentheses. So that's exactly how you're going to enter it. You go times, open parentheses, 1 plus 0.0425 times 6, close parentheses. Make sure you're opening and closing parentheses. And when you enter all this into your calculator, you get $31,375,000. So you put a certain amount of money, that is $25,000, into an account at the beginning of time. It's a lump sum, and then just leave it in the account for 6 years. And if the account interest rate is 4.25%, at the end of 6 years, you're going to collect $31,375. Now let's read on. We have now $31,375. Now this amount is now transferred into another account. Okay, so this is a different account. The rate is 5.5%. Remember that it's not enough to know just the rate. We need to know what kind of interest it is. So it's compounded monthly. The minute it's compounded, we need to know how many times. So we know it's monthly, which is n equals 12 times for the rest of the time. So we don't know what that time is, but what do we mean by the rest of the time? So let's read the question further. It says, if the child goes to college at the age of 19, how much money do they have in the account? So we know that the total amount of time that the money stays in the account is 19 years, out of which we've already invested the money into a simple interest account for the first 6 years. So what is left is 13 years. So for the rest of the time, so what do we mean by the rest of the time? The rest of the time would be 19, which is the total time, minus the 6 years that it sat in the simple interest account. So the total is 13 years. So that's the total amount of time that we're going to invest in this second account. So let's quickly write down. So this is step 2. Remember, it is compound interest. So now the present value is really this amount that we collected at the end of 6 years. This is going to be the beginning amount, $31,375 is the beginning amount in this new account, which is a compound interest account. The rate is converted to a decimal value, so that's 0.055. The amount of time that it stays in this account is T, which is 13 years. Remember that the interest is compounded. The rate of interest we already know. It is compounded monthly. So monthly is there are 12 months in the year. So N equals 12. Now the formula for A for a compound interest account is A equals P times 1 plus R over N whole to the N times T. So make sure you're putting parentheses everywhere necessary. So when you enter it into your calculator, you will not make mistakes. So we are entering all the numbers into this, or rather substituting all the numbers into the formula. So we have 0.55 divided by N, which is equal to 12, whole to the, in parentheses, 13 is the time, 12 is the number of times it is compounded. So the way you're going to enter this into your calculator is 31375 times, open parentheses, 1 plus 0.055 divided by 12 to the, open parentheses, 13 times 12. Enter it into your calculator to get 64,031 and 67 cents. So in the second account, we start with 31,375, which was the ending amount in the last step. We leave it in this account for 13 years at an interest rate of 5.5% compounded monthly, and at the end we collect 64,031.67. That's the amount we collect after 13 years. But notice that this is a two-step process. We started off with $25,000, and at the end of 19 years, we have 64,031 and 67 cents.